A very warm welcome to all of you. I, Akash Sharma, on behalf of Midas IT, welcome you all to this webinar on foundation module of Midas SoilWorks. So talking about today's workflow, first of all, I'll give you a brief introduction about the software, that is Introduction to SoilWorks, what exactly the software is about. Then the theoretical background of the PY nonlinear analysis on which the foundation module of SoilWorks works. Then what exactly, how the PY nonlinear analysis is done in Midas SoilWorks, and then we'll take a case study of a bridge pier foundation design. The main objective of today's webinar is that how can we generate the spring stiffness which could be provided in the structural software like structural big software like Midas Civil, etc. So first of all, talking about Midas SoilWorks. Midas SoilWorks is all-in-one 2D finite element analysis and analytical software which can be used both by structural and geotechnical engineer. It has its own fully integrated pre-post engine and its own solver. Midas SoilWorks is divided into 7 modules which are slope, ground, rock, soft ground, foundation, seepage, and dynamic. Slope is a module where you can perform the slope stability analysis, where you can perform the analytical methods like limit equilibrium method, as well as finite element method like strength reduction method for slope stability analysis. Then you have ground module where you can perform the construction stress analysis which can be used for short excavation or tunneling. Then you have rock. Rock is basically where you can perform the stereographic analysis and you can consider 3D slope stability analysis considering various material models which could be used to simulate the rock behavior. Then you have soft ground where you can perform the consolidation analysis, both analytical as well as the finite element analysis. After that, you have the foundation module today which we'll be taking in detail. Seepage analysis, you can perform the transient as well as the steady state analysis. And finally, you have the dynamic analysis where you can perform the eigenvalue. You can perform the eigenvalue, response spectra, time history analysis, as well as the free field analysis. So moving on, first of all, the theoretical background of the PY nonlinear analysis. Recent MATLAB conducted a lateral load test for various types of soils and proposed the soil response curves, which compiled the magnitudes of the subgrade reaction at various depths relative to the pile deflection beyond the elastic limit until the yielding of the soils. Now, whenever the lateral loads act on a pile head, especially in case of the soft soil, the soil stress easily exceeds the elastic limit, even under small external loads. Now, in such a case, the nonlinear soil response curves need to be used. Otherwise, a wide difference between the actual behavior and the analytical behavior is expected. So as a result of which the PY nonlinear analysis came into picture. Now, how exactly the PY nonlinear analysis is performed is, now different PY curves have been developed for different soil types. For example, American Petroleum Institute sand model, you have the sand Reese model. So different types of PY curves have been generated for different types of soil. Now, based on the input, if you just input that particular parameters, the PY curve will be generated for that particular soil type, which I will be telling you in detail. Now, what exactly it does is that it reflects the non-linear behavior of the soil. Okay. Now, if we analyze the summary, the pile is a divided beam, the soil is a non-linear spring. Now, PY curve will be the input parameter, which will define the non-linearity of the spring. Okay, so first of all, when the analysis takes place, the deflection of each pile segment is calculated. Depending on the deflection, the calculate resistance, the program calculates the soil resistance from the PY curve. Now, deflection and soil pressures are interconnected. So what exactly it is done that the program keeps on iterating the value based on the finite difference method till it converges to a point. So this is how exactly the PY nonlinear analysis works. Now, as I said that different PY curves have been developed for different soil types. Now, SoilWorks supports the PY curves for sand. Now, we have different models. I will just show you at the time of demonstration. So, like for sand, you have the sand API and sand grease. Then you can incorporate, you have the curves for clay, C5, soft rock, and hard rock. Also, you can input directly the PY curves from the field into the program for your particular type of soil. Okay, so moving on. So this is how exactly the PY nonlinear analysis elements are being used in the analysis. For example, you have the soil element, which is nothing but the nonlinear point spring, which is modeled as nonlinear point spring. Then pile element is modeled as beam element. The foundation element is basically a rigid link. The load acting on the pile head will be a nodal load. The pile head boundary is basically defined with the help of beam and release. Pile tip boundary with the help of support boundary. So now I will move on to the program. So today the problem which we are taking is, we are considering a soil model in which we are considering alluvial soil, which will be modeling as sand API. And then we have the weathered soil, which will be modeled as sand grease model, so that you can see that what basically the input parameters you require to model the ground. And then you have the water level, which is at 7 meters below the ground surface. So how can you consider it in the model will be demonstrated. Then the design load, it will be basically a load coming from a single pier from a bridge. So we are considering Vx, as you can see what is Vx in the figure demonstrated. Vx will be taken as 3140 kilonewton. P, that is the self-weight, will be minus 89187. As the program, you can see that P is directed upwards, so we will give it a negative sign. And we are considering My moment, which is 24120, and the load state is normal. Okay, so this is our load for which we have to design our foundation. Okay, now the footing size we will be considering is breadth of 11 meter, length of 18 meter, and a depth of 1.5 to 2.5 meter. Okay, then you have the pile, which will be using an Indian standard M40. Section will be circular and diameter being 1.5 meter. So this will be basically, you can perform a parametric study. So what we'll be doing is that we'll be considering two types of pile arrangement for the same footing, and we'll consider two types of pile arrangement, and we will see that how exactly we get the results, or what are the results which we get from the program. So I'll just move on to the program. Okay, so this is the interface for SoilWorks Foundation module. So whenever you start, just click on foundation, and what you have to do is you have to just move from left to right to complete your modeling part. Okay, so first of all, we'll start with the ground material property. As I already told you that what are the various model types which are supported in foundation module are clay, sand, C5, soft rock, and hard rock. I'll quickly demonstrate what are the input parameters required for each of the model type. For example, when you have clay, the input parameters are unit weight, saturated unit weight, cohesion, and for PY analysis, curve generation, strain at 50% stress, unit ultimate skin friction, unit ultimate bearing capacity. This is for soft clay. Now you can consider soft clay and stiff clay. So as you change stiff clay, you have to input an additional initial horizontal subgrade reaction for this. Okay, moving on, sand. So this we will take in detail, because in our model we have to take both. We have the sand soil grease and the sand soil API. Then I'll move on to C5. C5 is nothing but silt. So gamma saturated C5 are the basic parameters. Then you have to input the same parameters as you have inputted previously for soft clay. The stiff clay. Then you have the soft rock. So the material type will be vuggy limestone or the weak rock, and similarly the input parameters changes. And finally you have the hard rock. Once again, the material type, depending on the material type, the input parameter changes. So today we have to deal with sand. So first we'll take alluvial soil. Okay. So The unit weight, I'm just taking it as 16, saturated unit weight as 18, and the internal friction angle of 25. Okay. Now the material type is sand soil API. So I have to input the unit ultimate skin friction, which is 20, and then I have to unit ultimate bearing capacity, which is 600. Now basically what we are doing is that we are using the sand API model. Now with these parameters, the program will automatically generate the PY curve for this particular soil type, which is alluvial soil. Just correct the name, alluvial soil for this. So these parameters will help us generate the PY curves. Now if you want the details exactly how the program is calculating, you can refer to our analysis manual. So how exactly these parameters are used to calculate the PY curve. So I will just say add. The first one is alluvial soil. The second one is weathered soil. Just name it weathered soil. The model type remains sand, and the unit weight is okay. The alluvial soil, I will just change it to 16. I will just say modify. Okay, now it's correct. So 2. The name is weathered soil. The unit weight will be 17. The saturated unit weight be 19. And the internal friction angle 26. Now I'm changing the model type, sandy soil grease. Now once again it's a different model type which is used to generate PY curve. So based on this model type, you have to input additional parameter of initial horizontal subgrade reaction. Okay, so which is something around 16,000. Okay, the unit ultimate skin friction, I'm taking the value as 30, and you have the unit ultimate bearing capacity of 4,000 kilonewton per meter square. I will just say add. Okay, so these are our basically two soil types which we'll be using, as I already told you. So I'll just close it down. Now next, from foundation, we have to move on to the next icon, which is the structural property. As soon as you click on the structural property, you have the various element types. Okay. Now, what kind of pile you are going to use, whether it is steel pipe pile or PHC pile, cast in place or user defined pile. So for this, I'm just taking the cast in place pile. The various standards like AISC, STM, DS, Indian standards are there. So I'm taking Indian standard. The shape is round. Okay. So concrete, the grade of concrete I'm taking as M40, and the die I'm taking as 1.5 meters. All the stiffness parameter will be automatically calculated by the program. And finally, you have the material data which will be taken as per the grade of concrete which you are considering. So I'm naming it as pi 1.5. I'm just saying add. Okay. So as I already told you during the program and during the presentation, that I'll be using a one type of pile with two different types of footing. So I'm just closing it down. So I've already defined the pile. Okay. Now when you move from ground material property, structural property, next is the soil layer information. This is basically where you do the modeling. So if you have your own user defined PY curve, you can use it. But if you are using any sand material model, as we are doing right now, we are using sand API model and sand grease model for our model. So we'll be just defining it here. So I'll just name it as alluvial layer. Okay, the depth being, let's say, 5 meters is already shown, and then we have the weathered soil or the weathered soil layer, which is, let's say, 20 meters. And we'll just say weathered soil, and we'll just say add modify, close it. So this is basically we have modeled our soil layer information. Okay. Similarly, this was like for linearly varying layer. If the property is varying within the parameters, you can consider also that kind of modeling too. If the top layer and the bottom layer in the same layer are different, so you can consider that type of modeling. So next, moving from left to right, you have to define the foundation type. Now the foundation type is basically where you define your footing size and arrangement of piles. So let us define, let's say, pile footing 1. Okay. Now the width we have taken as 11 meter and the length is 18 meter and the height, let's say, 1.5 meter. Now the structural property, we are considering pile 1.5. The pile length, let us consider as 13. The number of rows, so it is in the x direction. So you can see this is the x direction and this is the y direction. So I'm considering 3. So left distance is basically the distance of the outermost pile. So since I'm considering a very symmetrical type of arrangement, I'm saying 3.75. And the number of rows in the y direction being 5 at an equal interval of, let's say, 3.75. Now I'm just saying add piles. So this is my pile arrangement. Okay. So even if you want to change the pile arrangement, because many times it couldn't be symmetrical, a few piles could be a few meters from the particular location, you can directly input the coordinate at this particular location, also the beta angle. You can also consider batted piles in Midas SoilWorks foundation module. Then what is the tip type? You can consider that, and the head condition could also be changed from here. For example, whether it's fixed hinge support or elastically restrained, or the tip type, whether it's free hinge support or fixed hinge. So I'm considering the tip type as free and the head condition as fixed. So I'm just saying add. Okay, now I will consider the pile footing 2. So the footing size remains same. Let us change the arrangement. So I'm saying it has 3 meters and 3 meters. So I'm just saying pile relocation. So you can see it has been relocated, and I will just say add. So I have 2 arrangements for the same footing, and we'll see that how we get the results for the same. So I'll just close it. Okay. Now we'll just move on to the next. Now define PY. The next is define PY curve. PY curve is basically if you are not using any material model to define your material property, then what you can do is that you can perform the test on the soil in the field, and you can just recommend our analysis manual for the same, and then you can generate your own PY curve and then directly use it as the material property to define the nonlinear spring stiffness in our model. Okay. So the next is the foundation load. So the load set. So I will just say the name as design load. Vx, you can see that Vx, I will take the force as 3140. It's in kilonewton. The load coming from the top or the bridge is minus 89187. Then you have the moment, which is 24120. The load state is normal. You can also consider the seismic state. So we have generated the design load. Close it. Now moving on to the next part, we have to define the water level. So water level, you can just name it, give it a name. Let's say WL, standing for water level. So what is the distance from the ground surface? Let us say 7 meters. Say okay. Now finally we have completed our modeling part. Let us see whatever information you have created goes on the left hand side. So if you want to edit anything, for example, the ground material property, you have the alluvial soil, then you have the weathered soil. Okay, soil layer information regarding the depth. PY curve we have used the model, so there is no So if you want to edit your two types, that is pile footing 1, so this is our arrangement, this is our pile dia. Pile footing 2, this is our arrangement, the dia remains same. Then what loads you have used, if you want to edit or modify, you can just right click and say modify, change it. And finally, you have the water level. So you can check in the figure itself where exactly the water level is for your model. Now, basically, we need to generate the analysis case. So we'll just go to foundation, analysis case, let's say add. Now we have only can perform the PY non-linear analysis. So first we'll be using as pile 1.5, that is for the dia, arrangement 1. So pile footing 1, activate only those footing which you want to consider. So in the same model, you can consider two types of footing. Okay. Then you have to then water level is activated, then the design load. So just say OK. Then once again you add the second, let's say pile 1.5, arrangement 2. So and rest of the things need to be activated and just say OK. Close it. Then foundation, analysis and report. And you can just perform the analysis. You can save the model and run the analysis. Okay. So just to save time, I'll just open an already analyzed model. So what results exactly we get from this analysis? Okay. So first of all, we get foundation design result. So what is the maximum displacement of the pipe? Maximum displacement of the foundation. So the vertical displacement, the horizontal displacement in the y direction, okay, the rotation. Then what is the pile maximum displacement and the maximum member force which we are getting? So you can get this one. Also this, you can just click on that particular pile and you will get the horizontal displacement, moment, shear force and the ground reaction coming for that particular model. Okay. And then you have the pile head maximum displacement and maximum reaction force. So displacement of foundation, and then I'll just show you detail. Okay. Now this is for example pile 1 location. Now here what exactly you get, as I was saying that after the analysis we get the PY curve at each location of the pile. Now initially we inputted the soil material behavior, but after the application of load, what spring stiffness should one structural engineer provide in a structural software like Midas Civil can be directly obtained from here. For example, first you got the maximum displacement, then you can see that pile number 1, which is the outermost pile. So at location 0 you get all the thing, and including that you get the PY curve. So at location 0 there is not much of requirement, but if you go lower down, when you click on PY curve, you will get exactly that how the displacement is occurring as a result of P. Now you can directly import this file, you can directly save this file and directly use it as a PY input to consider the nonlinear string behavior or nonlinear string stiffness in Midas Civil. So that is how you can get the spring stiffness considering the non-linearity of the soil. As I already told that you cannot consider, if you are not considering the non-linear behavior of soil, then there is a huge difference in the simulation of what you are doing. So you can get exactly with the different model types, you can get the behavior, how exactly each spring is behaving, and you can provide the stiffness at that particular location for each of the pile. You can just change the pile from here and you will get the pile stiffness or pile PY curve exactly, to be exact, for the PY curve. Okay. So these are the various results which you get, and the best part is you can do a parametric kind of study. For example, I have just checked for two footing type. You can change the pile size and the footing size too, and then run the analysis to get the results for your model. Okay. So just to go in detail, so this is the maximum displacement. This I already told. Then you also get the pile maximum displacement and the maximum force. in all the direction, for example, fx, fz, fy, then fyz. What is the maximum moment coming in my, mz or myz? Okay, then you get the pile display, head displacement and reaction. All these files can be directly exported to Excel, or you can directly use to create graph for your report generation. Now, talking about the report generation, the program automatically calculates a detailed report for you. For example, you can see that what are the foundation type, the summary with all the tables directly taken from the program. So you can see that what material property which you have used. So what is the displacement you are getting. So all the tables are directly imported in a Word format which is editable and can be used directly for the report generation, thus saving a lot of your time. Okay, so you can see that a well-detailed report is generated automatically by the program for the PY nonlinear analysis. So even if when you want to do the parametric study, for example, in the structural property right now, I've just created file 1.5. So what you can do is that you can just change the section. You can select, let's say, steel pipe as per the various IS codes. You can just define the different grades. You can define the section. Let's say 0.6. Let's say 1.5 be the dia. Just taking some values to just show you, and let's say 0.6 be the thickness. So you can just create such values. When you add, just change the ID and let's say pipe. So just add. Okay. Now it has been added. Now when you create the footing type, you just go to foundation. You go to the when you define the foundation type, you just in the structural property which you are using, you can directly change it to steel pipe and generate the relocation and generate different analysis case to study. Also, for example, as I was saying that, for example, I want to move this particular location. So you can directly change the location of this file by simply moving. Or what you can do is that you can directly change the X and Y location of the file to create create the exact location of that particular file. Okay. So this was all from the demonstration part. So moving on to the presentation. So you can do we have done the parametric study of the pile arrangement. And for today's, the main result interpretation was, as you have already seen, that you get a variety of results. But including all these results, you get the PY curves at various locations. It is automatically generated by the program and can be used directly for the spring stiffness in the bridge software in Midas. Now the advantage being that this stiffness is we are getting considering the non-linear behavior of the soil. Okay. So this was all from today's presentation. I will thank you all for attending this webinar session. Hope you find this webinar session useful. For any further queries, you can contact us as techsupport@midasit.com. Thank you.